Hello students, how are you? All good? I hope all are doing great at their homes, right? Going to schools and colleges. Keep it up. So today we will talk about reflection of light. I think everyone knows what is reflection of light. Am I right? Reflection of light by plane mirrors, how images are formed by plane mirrors. Before you go to school or any party, definitely we spend a lot of time in front of plane mirrors. Don't you agree for that? Absolutely yes. We take some time bit in front of the plane mirrors to see ourselves. What we see ourselves in the plane mirror is called as the image of the person. What kind of image is that? What kind of image is that? Is it a real image or is it a virtual image? Oh, images are of two types. Maybe someone listening to this for the first time, I'm not sure. So there are two types of images, real image as well as virtual image. So plane mirrors form what kind of an image? Is it real or is it virtual? And we'll talk about various laws of reflection and how the images are formed actually and all the intricacies related with plane mirrors. Everything you wanted to know about reflection of light with respect to plane mirrors. So today's topic for the class is reflection of light. Reflection of light by plane mirrors. Okay? By plane mirrors. Also very commonly called as looking glass. That is a very common name for plane mirrors. Now what are exactly plane mirrors? Plane mirrors, are they like transparent, translucent or opaque mediums? Okay, that's not a big surprise. I'm sure everybody knows about it. Plane mirrors are definitely very smoothly polished, opaque surfaces. Am I right? I was very stressful on the word opaque. Opaque subsurfaces or opaque mediums are those which do not at all allow the light to pass through them. Be clear about it. And transparent substances or mediums are those which allow complete passage of light, like solid piece of glass. Oh, you may just ask me immediately, sir, plane mirrors are also made up of glass. Absolutely yes. But you'll notice that the window pane and the plane mirror, there is a big difference. Window pane is completely transparent. You can see from one side to another through this solid piece of glass. But through the plane mirror, can you see what is on the other side of it? Absolutely not, because the back side of the plane mirror is coated with a substance which makes it opaque. There's a silver coating behind the back surface of the plane mirror which makes it an excellent reflector of light. So plane mirrors are good, or we can say excellent reflectors of light, because they are opaque mediums. So what are exactly plane mirrors and how to really show it up on a diagrammatic scale? We just try to show it with the help of a straight line, plane surface, and one side will be the polished surface. I was talking about the silver coating or the orange paint what you get to see, on which we don't get to see our images formed. The other side is the mirror. Alright? So when light is allowed to be incident upon a plane mirror, just like your stainless steel plates or any metallic sheet, you will find that the light, after being incident upon the plane mirror, a very smooth polished surface, you'll find the light bounces off in a well-defined way into the same medium. I mean to say, by the word medium, the light rays or the beam of light actually came from the air medium, strikes the mirror at the various points on the surface and bounces back into the same air medium. It cannot pass right through the mirror itself because it is opaque. I think we are doing good till here. Good. Now this is called a very specialized name. The very common name is that it is called as the regular reflection of light, or the better name would have been, it is also called specular reflection of light. This is called specular reflection of light. That's it. A mirror-like reflection. The specular reflection itself means it's a mirror-like reflection. On the other hand, you will see that the white pages of your copies or the board itself, which may feel very smooth to your fingers, but exactly in connection to the wavelengths of the light concerned, the surface is not as smooth and polished as the plane mirror or a stainless steel plate is. So here you will find the light being incident upon such kind of surfaces do not really bounce off in a well-defined way, or rather you'll find it bounces off in a very random directions. In which direction it will bounce off, we really cannot predict, but it is going to bounce off into the same medium through which it actually comes out. So this is called very popularly as irregular reflection of light, or you could have also called it as diffused reflection of light. So my dear students, one thing be sure, whether it is a rough bumpy surface or whether it's a very smooth polished surface, both the opaque surfaces does one thing in common. They are very good in bouncing off the light from the surface. Such bouncing off phenomena from the surface is called reflection of light. But there is a difference in the way they reflect the light. So one is called a specular reflection or regular reflection. The other one is called irregular or diffuse reflection. Mirrors perform specular reflection. The pages of the books or the board itself right now is performing irregular or diffuse reflection. So regular reflections are the ones which really form the images. That's why we can see ourselves when we stand in front of a plane mirror, but we don't get to see our own self in the white sheet of our copy books, or I can't see myself in this very smooth looking board right now. An image is not exactly formed. So one thing be very clear in your heads, the fact that we are able to see the things around with our beautiful eyes around is all because the light getting reflected from the various surfaces in your surroundings reaches to your eyes after getting bounced off from the surfaces. Such light is called as a reflected beam of light, which helps in the formation of images and hence helps us to see the things around. We'll also later on talk about the other phenomena called refraction of light. Later on we'll talk about dispersion, scattering, polarization, diffraction and interference of light. All the various phenomena exhibited by this electromagnetic wave, which we call generally as the visible part of the electromagnetic spectrum, also called as light. Till here, all good. I suppose you can please note it down if anyone is doing so. Right. Now, let's talk about the laws of reflection, which really governs how light actually gets reflected in case of a plane mirror or very smooth polished surface. The laws of reflection which we are about to discuss, I think many of the students may even know them, are not actually valid for irregular or diffuse reflection of light. Here I'd like to say very clear, the ability of us to see the moon, beautiful moon in the dark sky, is because the moon surface is an excellent or very good reflector of the sun's light. Since the body is actually very huge and at the same time very far away, it becomes very crystal clear in the dark sky by reflecting off the sun's light. That kind of surface is called, that kind of reflection, so to say, is called as diffused reflection of light. Let us quickly look into the case. What are the laws of reflection? What are the laws of reflection of light? It's very, very simple. I think very easy to understand. Let us imagine a plane mirror. This is the diagrammatic representation of a plane mirror. And definitely all of you know that. A single line, straight line with an arrow mark is what we call as a ray of light. This ray of light comes from point P strikes on the mirror at point O. After striking at the point O, instead of going straight through it, which is not actually possible because the surface is very much opaque to light, it bounces off just like a tennis ball bouncing off from a very smooth tile or a granite flooring. It bounces off into the same medium, going into some other direction called R. Be careful about these directions. P, O, then O to R. You can see there's a large angle created in between them. So as to differentiate between this angle between the PO and RO, we draw an imaginary dotted line which makes an angle of 90 degrees with the surface of the mirror. Such a line is called normal. What do we call it as? Normal. Is that clear? Right. Here PO, basing upon the direction given on this straight line, we will call it as incident ray of light. This is called incident ray of light, and the point where it strikes on the mirror, this is called as the point of incidence. The point of incidence. And after striking at O, it bounces off into the same medium but in a different direction. This ray of light, OR, is called as a reflected ray of light. This is called reflected ray of light. Here, the very important definition is of the angles, which a few students tend to confuse up. The angle formed between the incident ray and the normal is called as the angle of incidence. The angle formed between the reflected ray and the normal is called angle of reflection. But there is two more angles which is very clearly visible to all of us. The angle formed between the surface of the mirror and the incident ray. This is actually in fact called glancing angle of incidence, and the angle formed between the reflected ray and the surface of the mirror is called as glancing angle of reflection. So the first law of reflection states that the incident ray of light, the normal at the point of incidence, and the reflected ray of light all lie in the same plane. All lie in the same plane. In this case, all these three will lie on the plane of the board, or if you're drawing it on paper, all these three should lie on the plane of the page of your notebook. It means that after the light ray strikes onto the plane mirror, it doesn't come out of the plane of this board, out of it. That is not the case. That is the first law. The second law states that the measure of the angle of incidence is always equal to the measure of angle of reflection, which is very commonly written as the angle of incidence is always equal to the angle of reflection. For example, if this incident ray of light strikes the mirror at an angle of 60 degrees with the mirror surface, then the angle of incidence should be definitely 90 minus 60 is 30 degrees. If that is the case, the angle of reflection should exactly be 30 degrees. The remaining is again 60. So the total angle of a straight line is well known to all of us. It's 180 degrees. Please note down the diagram carefully. Hope I'm clear to you. There's some darkness created in this room right now, just to make you feel for what is reflection of light. Right in my hand, I have a plane mirror, I have a torchlight. You can clearly see that. Sorry for that disturbance. You can just see that on the board you'll find a patch of light coming up. Yeah. If you observe closely, the light is actually directed at a certain angle, as you can see there, onto the plane mirror, and you can clearly see a patch of light on the green board behind. Means the light has actually bounced off from the surface and the image has been casted on the board, the white patch of light. So there is a beam of light which is directly hitting upon, and you can clearly see the path of the beam of light and the dust particles even flying off That is called also by the name scattering of light by the dust particles. So when you put this plane mirror, you get clearly to see the patch of light on the board. What happens if I just allow the light to fall upon the mirror at perpendicular angles? You'll see that the patch of light is exactly behind the torch. You can even see that patch of light where it is striking the mirror from behind the mirror. It means that the plastic coating on this mirror is actually slightly translucent to the light. It's not exactly transparent, it is translucent, which means it allows the light to pass through partially. I hope you're getting some feeling for reflection of light. Okay, now let us see how an image is actually formed by a plane mirror. When you or me stand in front of a plane mirror before getting ready for something like school, college, or even for a party, we find ourselves very exactly the same in the mirror. What is that? What is that you get to see in the mirror? That is an image of yours. So you regard yourself as an object placed in front of a plane mirror, and what you see in the plane mirror is called as the image of the object. How exactly it is formed and what kind of image is that? As I told right in the beginning of this class, images can be of two types: real images as well as virtual images. So let us quickly see how an image is formed. Image formation by plane mirrors. All right. How an image is formed by plane mirrors. So let us quickly see into that. Let us assume this is the plane mirror. The polished back surface indicated by oblique lines. Please follow this ray diagram very closely. Let us choose the object in this case as a candle flame, which can be also said as a luminous source of light. Luminous source itself refers to a body which can produce its own light. Bodies which cannot produce their own light but depend upon other sources to be seen, they are called non-luminous sources. Planets are non-luminous, the moon is non-luminous, whereas the sun and the stars are luminous bodies. So we have chosen this candle flame at a certain distance from the plane mirror. Okay, let us call this distance as U, which means it is the distance of the object from the mirror. Okay, now what is going to exactly happen? Let us take this tip as A and the bottom part as B. A ray of light, in case if it goes straight on and strikes the plane mirror, just now I showed a demo about this reflection, the ray of light is going to bounce back and retraces its own path. In this case, please remember, please try to understand, it's a case of normal incidence. The angle of incidence and angle of reflection, which has to be equal because they obey the laws of reflection, has to be equal to 0 degrees. All right. So you find the reflected ray number 1 comes back. What if the ray of light strikes at an oblique angle at some other point? So do not forget to draw your perpendicular line, which we call as normal, and it should always pass right to the point of incidence, making an angle of 90 degrees with the surface. So the ray of light is definitely going to bounce off, making equal angles. So this is our angle of incidence. This is called as angle of reflection. What if a ray of light strikes from the bottom of the candle flame perpendicular to the surface? So here also you'll find the case of normal incidence taking place. So to reduce the complexity and to maintain the neatness of the diagram, we have chosen only 3 rays of light, and we can see the reflected rays bounce off into the same medium, but nowhere we see that the reflected rays are going to meet anywhere in the future. There will be infinite rays emanating or emitted by this body which go and strike off the mirror and bounce off. These reflected rays need to be really taken care of. If the reflected rays really or actually intersect at a point somewhere in the future, that point of intersection is called the formation of a real image by the mirror. But in this case, plane mirror doesn't look like forming a real image, because object is real and I find the image is going to be non-realistic, which we also call as a virtual image. Okay, let us diagrammatically see that what is a virtual image. Produce the reflected ray of light backwards, straight, geometrically straight. Reflected ray number 2, produce it backwards. Please do use your scales to draw these diagrams. Produce the reflected ray number 3, straight backwards. So here we find that these two reflected rays, when produced backwards, seem to have a common meeting point, and that meeting point is the image of the tip of the flame from where these two rays have been chosen from. So it marks the formation of the image of the candle flame, and the third ray just almost tells us we are going to get the bottom of the candle. Hence, an image is formed. So this distance of the image formed from the mirror is known by the name image distance, denoted by the alphabet V. So that is your image distance, this is your object distance. This is your image distance. And most of the times we have very much noted down that the height of the object, whatever is your height, if you're standing at a right distance from the mirror, you will get to see that the height of the image remains exactly the same. So this is the height of the image. So both the heights are going to be exactly equal. Now coming to most important properties is that the image is upright as just like the object. I mean to say the head is on the top and the bottom is at the bottom. The feet are at the bottom like. Okay? Such kind of images are called erect images. But this image is actually formed by geometrically producing the reflected beam of light and happens to meet or intersect at a point. Such kind of intersection is called virtual intersection, and such kind of images cannot be obtained on a screen, so they are called as virtual images, which are always erect. Virtual and erect image. And the fourth property is very interesting one. That is, you and me have done it n number of times standing in front of a mirror. Just raise your right hand. What do you see in the mirror? You will find that in the mirror the image seems to be raising its left hand. If I'm raising right in real, in the mirror it is left. If I'm raising my left, in the mirror it is the right hand. Means the sides have actually interchanged or reversed. That reverse or inversion is called as lateral inversion. Lateral inversion. Let me write it properly. Lateral inversion. So the images are always sideways inverted, laterally inverted. Okay, I hope all of you got my point very clear. If you have any issues regarding the topic, please do not forget to comment it below, and if you like the video, do share it among your friends. Don't forget to like it, and don't definitely forget to subscribe to my YouTube channel. Keep rocking, keep studying, be healthy. Thank you.